So first of all, in the figure, O is the center of the circle. So if the question doesn't tell you specifically that the point is a center, you can't just assume that it's a center, okay? So now we have the angle ACB. So angle ACB is here, which is 120 degrees. So we need to find out what's the angle of X and Y. So start from here, there's something, if you want to find out the X, basically it's just 360 minus the whole thing at the center, isn't it? So you can see from here, this angle 120 is watching to this major arc AB, so do this reflex angle AOB is watching to the yellow arc as well. So actually the reflex angle AOB is actually doubled of this 120 degrees, isn't it? So first of all, you can write the angle AOB, the reflected one, is equal to, or we can write the reflex angle AOB is equal to the doubled of the angle ACB. So once again, the reflex angle AOB, which is this one, is watching to the yellow arc. So to this 120 is watching to the yellow arc as well. So that they have the relationship which is doubled by using the theorem of angle at the center twice angle at the circumference. Then we can say that the reflex angle AOB is going to be equal to 2 times 120, which is equal to 240 degrees. So now, because the whole point is going to be 360 degrees, so to find the X, we're just using the 360 minus the 240. So we have the X is going to be equal to 360 degrees minus the reflex angle AOB by using the angle at the point. Then X is equal to 360 minus 240 is going to be equal to 120 degrees. So after you do that, if you want to find out what is the value of Y, it actually can be think about by using consider about the OA and the OB is a radii. So you can write it down, the OA is equal to OB because they are radii. Then we can say that the triangle OAB is an isosceles triangle, so that the angle OAB is equal to the angle of ABO, so that these three angles plus together will be 180 by using the angle sum of triangle. So we can write that X plus 2Y is equal to 180 degrees. Why we can write a 2Y here? Because this is going to be Y as well, just like what I said before, by using the base angle isosceles triangle. So if X plus 2Y equal to 180 degrees by using the angle sum of triangle, then X is equal to 120 plus 2Y is equal to 180. So using the calculator, it's going to be Y is equal to 30 degrees. So that's for question 10.1. So now we can do the practice 10.2. So first of all, they told you that O is the center, so this is the center, and we have PR is parallel to QO, and the PRO is equal to 42 degrees. We need to find out what is the value of X. So first of all, if these two lines are parallel, which means that this angle and this angle adding up will give you 180 degrees by using the interior angle. So first of all, we can write down angle PRO plus angle RPQ is equal to 180 degrees by using the interior angles for that the PR is parallel to QO, because this is PRO, this is ROQ. So these two angles plus together will give you 180 degrees. So we can say that the angle ROQ is equal to 180 minus 42 is equal to 138 degrees. So this one is going to be equal to 138 degrees. Then we need to think about what's the relationship between this angle 138 and this angle X. So think about it, this X is watching to the whole arc, major QR, isn't it? And so to this reflex angle, ROQ is watching to the same arc as well. So one angle is the angle at the center, this is the angle at the center, and the X, the required angle, is the angle at the circumference. So we can say that the reflex angle QR, so the reflex angle QR means this one is equal to the double double of angle QPR. So how can we find out this reflex angle QOR? We can using the angle at the point, isn't it? So the reflex angle QOR is equal to 360 degrees minus 138 degrees, which is equal to 222 degrees. So the reflex angle is equal to the double of QPR by using the angle at the center twice angle at the circumference. So the reflex angle is using the 360 because the whole point is 360. We minus the 138 to get this reflex angle. So by using the angle at a point. So now we can, using this formula again, to find out the reflex angle QOR is equal to 2 times x, because angle QPR is actually the x. So we have 222 degrees equal to 2x, which means that the x is equal to 111 degrees. So that's for this question. So for practice 10.3, first of all, we have the angle O is the center, and then we have the ABO is 38, and then we have ACO is 24. They ask you to find out x. So if you have an angle at the center, so probably you need to think about the angle at the center twice angle at the circumference. So think about this, x is watching to this arc. So do this angle BAC is watching to this arc as well. So our goal is to find out what's the angle here. But how can we find out this angle? So this angle is quite hard. Sorry. So this angle is quite hard to find out. But if we draw a straight line cutting through A and O, we join the point A and point O. So AX is equal to BX is equal to CX. So AX is equal to BX equal to CX because, sorry, the AO. OA equal to OB equal to OC. These three lines are the same because they are the line joining from the center to the circumference. They're calling as the radii. So the radii's length is the same. So then we can say that this triangle and this triangle are isosceles triangle together with the base angle are the same. So if this is 38, then the angle BAO is 38 as well. If this is 24, then the angle of COA is 24 as well. So we can say that the angle BAO is equal to the angle ABO equal to 38 degrees by using the base angles isosceles triangle, and we can say the angle of CAO is equal to the angle ACO. So CAO is equal to the angle of ACO, which is equal to 24 degrees by again using the base angle isosceles triangle, so that we can have the angle BAC is equal to 38 plus 24, giving you 62 degrees. So BAC means that the angle of BAC is basically just this two angles plussing together to give you 68 degrees. So now we have this is 38, 68, which is the angle at the circumference, and then the angle at the center, which is x, is doubled of this angle BAC. We can say that the angle BOC is equal to the doubled of angle BAC by using the angle at the center twice angle at the circumference. Then we can say that the angle BOC, which is x, which is equal to 2 times 62, giving you 124 degrees. So that's for question 3. So now we are going to do the question 4. So if you see from here, AB is a semicircle. So semicircle means probably you can using the angle in semicircle. So try to use this theory to do these questions with the center O. And then if the AB is equal to OB, you need to find out the angle of OAC. So if you want to find out OAC, which means that if we know this angle, then we can using the angle in the semicircle to minus the 90 minus this angle to get the required angle. So our problem is now going to find out what is the angle BAO. So as we have AB is equal to BO, but BO is actually the radius from O to B, which is the same as OA. So now we have the OA equal to OB equal to OA equal to OB by using the radii, so that it's equal to AB as well. This is given. So if three sides of a triangle are the same, that triangle is an equilateral triangle. So we can say that the triangle OAB is an equilateral triangle. So we have the angle of BAO is equal to 60 degrees. So this angle of BAO is equal to 60. Then we can say that the angle of BAC is 90 by using the angle in semicircle. And then we have the angle BAC is 90 degrees by using the angle in semicircle, so that the angle of OAC, the required angle, is going to be using the whole angle BAC minus the angle BAO. So the required angle OAC is using the whole angle minus this angle to get the required angle here. Then we can say it's equal to 90 minus 60 give you 30 degrees. So that's for question 4. Alright, so for question 5, in the figure, D is a point. So they didn't tell you that D is the center, so you can't assume that, although it looks like, but you can't assume that this is the center, okay? So D is a point on AC, such that the AB is equal to BD, and now we have the angle of BAD is equal to 59 degrees, and the angle CBD is equal to 26 degrees. Determine whether the AC is diameter of a circle. If you see any questions they're asking whether a line is a diameter, you need to think about the converse of angle in semicircle, which means that if you have an angle at a circumference which is 90 degrees, then the 2 points lining up will be the diameter of the circle. Okay, so let me see. We want to prove that the angle of ABC is 90 degrees, then we can say that AC is a diameter. So now we have this is 26. The only thing we need to prove is this angle is equal to how many? So now we have these two lines are the same, so we can say that the angle of ABD is the isosceles triangle, so that the base angle are the same. So first of all, we can say the angle of ADB is equal to the angle of BAD. So angle of ADB is equal to the angle of BAD because they are isosceles triangle by using the base angles isosceles triangle. So this angle is equal to 59 as well. So then we can using the angle sum of triangle to find out the angle of ABD. So we have the angle of ABD plus 59 plus 59 plus 59. So angle of ABD plus 59 plus 59 will give you 180 degrees by using the angle sum of triangle. So we have the angle of ABD is equal to 62 degrees. So now we need to consider about the angle of ABC, which is equal to the angle ABC is actually equal to the angle of ABD that we found here is 62, and then plus the angle of CBD, which is 26. So it's equal to the angle of ABD plus angle of CBD, which is equal to 62 plus 26 gives you 88 degrees, which is not equal to 90 degrees. So we can prove that the AC is not a diameter. So even if only if this angle ABC is equal to 90 degrees, then we can say that AC is a diameter. So that's for question 5. So now we're going to do question 6. So in the figure we have PR is the diameter and SQR is equal to 6 degrees. So what we're going to find is this angle X. So first of all, if this is the diameter, then we can properly find a 90 degrees by using the angle in semicircle, and our 90 degrees is properly here. So this PQR is our 90 degrees. So we can write it down. We have the PR is a diameter, so that the angle of PQR is equal to 90 degrees. So if the whole thing is 90 degrees, means the PQS is gonna be 90 minus 36. So we have the angle of PQS is equal to 90 degrees minus 36 degrees, which is equal to 54 degrees. So the reason why this is 90 degrees, we're using the theorem of angle in the semicircle. So now we get this angle is 54 degrees. So we can write it down. this is angle 54. So this angle 54 is actually watching to this PS. These are PS. So do this X is watching to this PS as well. So we can say that X is actually just